All right, we're going to do problem 41 from page 458. All right, let me read it first. Aviation. The cruising speed of a Boeing 767 in still air is 530 miles per hour. That will be one of the vectors there. Suppose that a 767 Boeing is cruising directly east when it encounters an 80 mile per hour wind blowing 40 degrees south of west. All right, so we've got two things in play here. We've got an airplane. This airplane is going 530 miles per hour, and it is going directly east. All right. We also have wind. The wind is going 80 miles per hour, and instead of straight up or down or left to right, it is going 40 miles south of west. That 40 miles south of west is going to create a problem. 40 degrees south of west. But we're going to have to deal with that. Okay, letter A. They want us to sketch the vectors. So there's two vectors. There's the airplane and the wind. I'll use two colors here. I'm going to use red for the airplane, and I'll use blue for the wind here. All right, so we're going to just sketch them. Part A. So, north, south, west, east. The airplane is, this one's easy to do. This one is simply a red line going east. The magnitude of this vector is 530 miles per hour. That's the airplane if there was nothing impeding it. There's going to be the wind vector. And I'll do this guy here in blue. It's going 40 degrees. So I'll put 40 degrees south of west. So I'll put a little 40 right there. And the vector number is 80 miles per hour. So that is 40 degrees, not to be confused with this 80 there, which is 80 miles per hour. Okay, so 40 degrees. All right. Part B. So those are two vectors. Express both vectors, the airplane and the wind, as ordered pairs. So the airplane is going to be fairly easy. Where does this thing end up? 530, comma, up and down 0. 530, comma, 0. Doesn't move up or down. The wind, however, is going to require a little bit of work. So let's kind of look here at the wind. And in particular, this thing is a right triangle. This is 80, the miles per hour of that wind. We have to figure out this x and this y. And we have 40 degrees right here. 40 degrees south of west. So we're going to use sine, cosine, tangent twice. Let's solve for x here. This is adjacent hypotenuse. We would say cosine 40 degrees is x over the hypotenuse 80. Go to your calculator. This one ends up being 61.3 degrees. Oh, not degrees. 61.3. To figure out the y, the up and down number, this is opposite hypotenuse, so that's sine 40 degrees, y opposite over hypotenuse 80. Throw that in your calculator, you get 51.4. All right, so what is the location? Well, it's negative, negative. Negative 61.3, which implies going west, comma, negative 51.4, which implies going south. All right, that's part B. Part C, find the sum of the vectors. What is the sum of the plane and the wind? So here's part C. What is the sum of this? So if I add 530 and negative 61, it is 468.7. 0 minus 51.4 is negative 51.4. So just add. Now they didn't ask us to graph that result, but here's the airplane wanting to go in red directly east. Here's the wind pushing it this way, going at 40 degrees southwest. What is the actual flight pattern of this airplane? It would go 468 down 51, and it would end up like this green line here. All right, it wants to go directly east. It gets slightly pushed off kilter and ends up here. All right, so now part D. What is the magnitude of this green line and the direction of this green line? So magnitude is really speed. So we're going to calculate the magnitude of this green line, which again is speed in this particular case. Normally it goes 530 miles per hour, but I'm sure this green line is going to be slowed down because the wind is going against going east. We also want the direction of this thing too. So let's take a quick look at this green line in greater detail. Let's see, I might have to lift up this sky a little bit or just shift down. This green line, the route of the airplane. Well, we know that left to right, it is 468.7. Up and down is 51.4. We don't need the negative, it's just 51.4 south. We want the magnitude of this guy. We just do a little a squared plus b squared is equal to c squared. And if you do that correctly, this thing is going 471.5 miles per hour. So the green line is 471, which is slower than the plane in still air. If it was just going east and there was no wind, he'd be going faster. But as it is, he's actually going 471.5 miles per hour. The other last remaining thing we got to figure out is the direction of this vector. We need this angle right here. I'll put an A there. I'm kind of running out of room. So we're going to say opposite, adjacent. We're going to say angle A is tangent, inverse tangent, 51 opposite adjacent 468.7. Throw that in the calculator and you get 6.3 degrees. So the direction is 6.3 degrees. This guy's going, here's north, south, east, west. He's going south of the east line, 6.3 degrees south of east. And that is the direction of the actual plane path, fighting the wind. This is his end result. And that is 41.